Yeah, hello friends. Hi everyone. Welcome back to today's YouTube live session. Myself Sachin Zavre from AiSPRY working as associate data scientist. So I'm very super excited to show you something that combines the power of AI, natural language processing and speech over every own voice assistant with speech to text and open AI API. So in day-to-day life, you all used Alexa, Google Assistants, or Siri, right? Now imagine building your own version but smarter, one that understands multiple languages, works even in noisy environment, and can analyze and analyze what people say to give real-time insights. That's exactly what is this project about. By the end of the session, you will know how audio goes from a simple microphone input and to an intelligent AI response, and how we can use this system for analytics and agent performance evaluation. So let's get started. Here's our project title: Voice Assistance with Speech to Text and Open API. The main goal to build a multilingual, noise-resistant voice assistant that can talk, understand, and respond just like a human, and even analyze conversation automatically. It's it's not just about convergent speech to text, it's about understanding meaning, tone, and intent of a customer. So now let's talk about the business problem we want to solve. In Indian call centers or customer support setups, agents switch between English, Hindi, Telugu, or Tamil, sometimes in the same sentences. Existing systems struggle with that. They either lose accuracy or can't handle the background noise. So we decided to develop a hybrid multilingual ASR system, one that understands code switched speech, filter noise, and extract useful insights from the con- conversation, like what went well in the call and what needs improvement. Now, every project comes with some real world constraint. We also have our three constraint business constraints. The first one is background noise. Since call happen in busy or open environments. Second, limited computing power. We can't always depend on the GPU or servers. And third, data privacy, the main important thing. Because these calls involve customer information, so we must follow strict policies. These factors shaped how we design the architecture: lightweight, efficient, and privacy compliant. The main objective was simple but powerful. I'm talking about business objective. So this application improves transcription accuracy from about 70% to 90 plus percent for Indian languages and automate the analytics process. This means no more manual QA listening to hours of calls, which leads to time consuming. The system itself identifies winning metrics, how confident an agent sounds, and improvement areas like tone or hesitations. talking with the customer. So every applications depend on the success criteria. And how do we measure success criteria? We define into 3 stages. The first one is ML success, business success. The second one is business success. The third one is economic success. So in ML success, what we have find out: high transcription accuracy, better noise handling, and effective sentiment extraction. Business success criteria: better sales conversion and happier customer. Economic success criteria: reduce manual effort, ideally cut QA cost by 60 to 70%. So success here isn't just accuracy, it's real business impact. So I will discuss about my third slide, architecture diagram. Here is the brain of our system, the architecture diagram. Let me walk you through the flow. The step one: the user speaks into the microphone, a simple microphone. Okay. Then the system performs noise reduction, voice normalization, and silence streaming to clean up the audio. The third step is the clean audio goes into speech to text model. This could be OpenAI, Whisper model. For example, Whisper model, Gemini 2.5 Pro, and high accuracy ASR models, which we have implemented to get the accuracy. The fourth step, the text output is then sent to OpenAI GPT, which interrupts the intent of an agent and generates a natural language reply in transcription form, what agent have speak with his customers. The final stage, the response is passed through a text to speech model so the assistants can talk back, and we can generate this transcription. I will go to the next slide. Data understanding. Before any model building, we had to understand the data, the main part, where we dealing with the raw, unstructured audio signals. So first step in the data is pre-processing is the key. We apply noise reduction, normalization, to normalize the audio, and trim silence to get clean data. Then we analyze the text output to detect intent, keywords, or even emotional tone where the customer sounded happy, confused, or upset. The fourth slide is model building. This is where all the components come together. The first, Gemini 2.5 Pro, comes in picture. Speech to text model handles transcription where we used free API key, which is Gemini 2.5 Pro. OpenAI GPT model understand contents and generate meaningful replies. The libraries we used includes speech recognition, OpenAI, and Streamlit to build our model. We have built the model in Streamlit, makes it super easy to build an interactive web application. So the assistant isn't just a script, it's like a full UI experience to a user who uses this application. The next slide I will go with is module evaluation. Model evaluation is nothing but the model testing part. How much accuracy the model gave me after doing after building the after model building. Once model is built, we evaluate our system. For evaluation, we added few metrics which includes word error rate for speech to text accuracy. Then response latency, how fast the system replies and generates the transcriptions. We also check the user experience, how natural the conversation feels and how well the assistant handles errors or interruptions. So this leads to us like continuous improvement happens through users feedback, what users gave feedback to us, and every new data helps fine tune the module and generate more accuracy rate. I will just go through the UI interface of mine. This is the example where we have built a sales analytics dashboard where two where there are customer and agent. Agent is calling to customer. So over here, total calls are made till now. Then these are the connected calls with the customers. Unique calls we have defined such as the customer who are interested to buy the product or they says in the transcription, I'm interested, I'm okay, I will go with that. They are converted into unique calls, and repeated calls are nothing, just are we have defined them missed calls. Then we have agent dashboard also. In agent dashboard, we got the agent performance. The second UI interface of our application is call analysis dashboard, the main part, where we used Gemini 2.5 Pro API key, free API key, where we can upload or load the data by the date wise using calendar metrics, where we can select any date So here is the date selected and here is the transcription. Okay, so Gemini, how Gemini 2.5 Pro help us in this? He have the key initially save the file name as agent name, and when he called, okay, at the start, Vivek underscore 25 2025 10 24. Okay, so this is the agent name and the transcription. We can listen the audio also, while below that transcription are generated. There are summary part and insights also. So how we have got this agent name? For this, we have made 12 different dimensions where an agent Start the call, such as, "Hi, this is Vivek calling you from XYZ company." So through that, it gets saved by the file name. So these are the UI improvements and winning and rating score of our agent. The call summary. So duration, he spoke for 7 minutes 46 seconds. He got rating 10 out of 8.3. Winning moves, listening responsive. Winning moves comes in that it first one is listening responsiveness and the speaking rate, and improvement. Pause parameters I can define like how much pause he took while speaking with agent. The agent was satisfied or not. He was hurry to sell his product, and he should talk slightly longer with the customer. In the winning, the agent was silent. He was good listener. Sorry, he was the good listener. He understood the customer's problem and replied to it. So this was all about my application, and that wraps up our session. We build a real-time multilingual AI-driven voice assistant that listens, understands, responds, and even evaluates human performance. The future of conversational AI is right here. So I would thank you all for listening. And if you found this inspiring, go ahead and build your own voice assistant next. Remember one thing, the best way to learn AI is to build AI. Yeah, thank you.